Use Case Review for RF Channel Reconfiguration, brought to you by Rimedo Labs, Juniper Networks, and Keysight. The concept of beamforming in Massive MIMO is a game-changer technique that stands as an enabler of achieving high user throughput. The main idea is to equip base stations with antenna arrays built of tens or even hundreds of elements. Large antenna arrays are used to formulate narrow spatial beams that can simultaneously serve multiple users. One of the key challenges reported in the context of Massive MIMO technology is increased energy consumption. Compared to single antenna systems, Massive MIMO requires much more hardware for processing of the radio signal related to each antenna. The problem is that increased power consumption is not always compensated by the user throughput improvement, especially during periods of low usage. Therefore, there is a demand for intelligent algorithms that can adapt the number of active RF channels to the traffic load to achieve power savings. Rimedo Labs, Juniper Networks, and Keysight have collaborated to demonstrate a solution to this challenge. RF Channel Reconfiguration xApp provided by Rimedo Labs is onboarded to Juniper Networks Near-RT RIC. This is connected to Keysight's RICtest solution, providing RAN simulation and stateful E2 interface communication. The xApp processes configuration information from the RAN and collects usage measurements. The xApp produces output to define an updated Massive MIMO antenna array configuration, which is applied through the ONES policy configuration structure using CCC service model. The scenario conditions for validating improvement brought by the xApp are described here. There will be 10 3-sector sites in the RAN simulation using Massive MIMO with 8x8 antenna arrays. A global traffic model is distributed across the subscriber population that creates demand and also opportunity for energy savings. The Rimedo Labs xApp will apply one of 3 different antenna mask options: full panel default, which is 8x8, half panel 4x8, and quarter panel 4x4. Let's review the simulation results. Our first demonstration is a time-accelerated video of the 6-minute test duration. Here we applied the global throughput model. The xApp is not onboarded, so there are no control messages. This means all antennas are operating at the 8x8 antenna panel default. Over the course of the test, we observe a global average power. The graph at the bottom is our global PRB utilization, and we see that this is running at about 50% of the available PRBs. Let's review the simulation result. In the scenario without application onboarded, we applied the throughput as a control. We do not see control messages because the xApp is disabled, and all antennas are running at a constant 8x8, consuming the most energy. This control yields a baseline energy profile. In our next demonstration, we see an onboarded xApp, the exchange of E2 setup, subscription, and control messages, as well as indications. We see that our xApp is onboarded successfully and is working with our scenario. In this next part, we have an accelerated video showing the 6-minute test being executed with the xApp enabled. Here we see subscriptions and control messages. These control messages are being applied and are doing RF channel reconfiguration for reduced energy consumption. These control messages are sending configurations for half panel and for quarter panel opportunistically as appropriate for its algorithm. We can look at the results to verify the energy savings. In test number 2, the xApp was activated, and we applied the global traffic model for throughput as control. We were able to observe control messages to manage the RF channel reconfigurations from the RApp to the RAN. The test resulted in throughput maintained with a reduced energy profile. In summary, the xApp testing observed an energy savings. The RF channel reconfiguration xApp intelligently scaled the number of active antennas to the traffic demand. For this scenario, about 67% reduction in power consumption was observed without disturbing UE downlink throughput. In this collaboration, the Rimedo Labs RCR-xApp was onboarded to Juniper Networks Near-RT RIC and verified against an openran network emulated by Keysight RICtest. For more information on RF channel reconfiguration, please reach out to one of us. Thank you for watching.